Our video tutorial this time is about annuity. Let us define some very basic terms regarding annuity. Annuity is a sequence of equal payments or deposits made at a regular interval of time. Simple annuity, an annuity where the payment interval is the same as the interest period. General annuity, an annuity where the payment interval is not the same as the interest period. Ordinary annuity, a type of annuity in which the payments are made at the end of each payment interval. Term of an annuity, T, the time between the first payment interval and the last payment interval. Periodic payment are the amount of each payment. Amount or future value of an annuity, the sum of future value of all the payments to be made during the entire term of the annuity. The present value of an annuity, P, the sum of present value of all the payments to be made during the entire term of the annuity. We have here a timeline starting from T equals 0, 1 up to N. The dots represents the periodic payment R. So this is the time diagram for an N payment ordinary annuity. Example, suppose Mrs. Manda would like to deposit 3,000 pesos every month in a fund that gives 10% compounded monthly. How much is the amount of future value of her savings after 6 months? So given 3,000 pesos, the periodic payment every month, 9% as the interest rate per annum or nominal rate, 9% in decimal 0.09. Compounded monthly, M equals 12, number of conversion per year. It is asking for the amount of future value, F. 6 months is the time, 6 months or 0.5 year. So we are going to determine the interest rate per period, J equals I over M. I is 0.09, M is 12. So this is the value. Number of conversion period N, M times T. So 12 times 0.5 is 6. Then we have here our timeline starting from 0 to 6 because N is 6. The dot represent the payment. The payment of 3,000 every period. So we have determined the J and N. So this 3,000 at the end of the term accumulates 0 interest. So it is still 3,000. This 3,000 will earn interest within 1 period. So using the compound interest, it is the exponent is 1. This 3,000 will earn compound interest within 2 periods, so the exponent is 2. This 3,000 will earn interest within 3 periods, so the exponent is 3. Similarly, this 3,000 will earn interest within 4 periods, so 4. And this one will earn interest within 5 periods. So let us determine the sum of these values. 3,000. This one, add, then raise to the first power, then multiply with 3,000. Raise to the second power, then multiply with 3,000. Raise this to third power, then multiply with 3,000. Similarly, raise to the fourth power, to the fifth power, then multiply with 3,000. So this is the amount of annuity F, 18,340.89 pesos. Now let us solve the same example using formula. So formula for future value. So the future value of an annuity, ordinary annuity with regular payments are at a nominal interest rate I, compounded M times a year after 3 years is equal to this formula, where F is the future value, R as the periodic payment, J is the interest rate per period, N is the total number of conversion periods or number of payments. Okay. Now let us solve this same problem using the formula. Suppose Mrs. Manda would like to deposit 3,000, so R is 3,000. 9% is the nominal rate, 0.09. Compounded monthly is M equals 12. How much is the future value F? 6 months is the time. 6 months is 0.5 year. Okay, J is I over M. N is M times T. So 12 times 0.5. So using the formula for the future value, R is 3000. Substitute J, this value, N 6. Then simplify. Then raise to the 6th power. Then subtract 1. Then divide by the denominator 0.0075. Then multiply by 3,000. F is equal to 18,340.89 pesos. So the same value as we obtained using the previous solution. Example 2. To start a business, Jake wants to save a certain amount of money at the end of every month to put in an account providing 2% interest compounded monthly. His estimated startup capital is 150,000 pesos. If he wants to start a business in 1.5 years, how much monthly deposit must he put into the account? So 2% is the nominal rate. In decimal, 0.02. Compounded monthly, M equals 12. This 150,000 pesos is the amount after 1.5 years. So that is the future value, 150,000 pesos. T in 1.5 years. It is asking for the monthly deposit, R. Okay, so let us solve for J and N. J is equal to I over M. I is 0.02, M is 12. N is M times T, M is 12, T is 1.5. Then substitute in the formula. F, the future amount, is given. The only unknown is R. J is this value, N is 118. Add, then raise to the power of 18. Then subtract 1. Then divide by this denominator. Then divide both sides of the equation by the factor of R. Cancel out. So that when we divide the periodic payment, the monthly deposit to be made by Jake is 8,215.90 pesos. So that after 1.5 years, he has a future value of 150,000 pesos. Okay, for the formula of future value and present value, future value and the present value formula. Okay, R is the periodic payment, J is I over M, the periodic rate per period, N is the number of payments or total number of conversion periods. I is the nominal rate, N number of conversion periods per year, time in year. Okay. Suppose Mrs. Manda, the same example, the same problem as we have previously, but this time let us solve for the present value. We have solved already the future value. Okay, R, the predict payment, 3,000. 9% as the nominal rate. Compounded monthly, M equals 12. It is asking for present value P times 6 months or 0.5 year. So let us solve for J and N. So substitute I, 0.09 and M is 12. N is M times T, M is 12. T is 0.5. Then using the formula, R is 3,000, J is 0.0075, N is 6. Okay, raise this to the power of negative 6 and subtract this from 1. Then divide this by the denominator. Then multiply. The present value of Mrs. Manda's deposit is 17,536.79 pesos. Okay. Next example. A certain fund currently has 100,000 and is invested at 3% interest compounded annually. How much withdrawal can be made at the end of each year so that the fund will have zero balance at the end of 12 years? Okay, for the given, we have this 100,000 as the present value. 3% interest per annum, 3% of 0.03. Compounded annually, M is equal to 1. It is asking for the withdrawal every year. So the unknown is R, the yearly withdrawal R. So that at the end of 12 years, T equals 12 years, there is zero balance. So let us solve for J and N. So J is I, 0.03 over M, 1. N is M times T, M is 1, T is 12. So, substitute P equals 100,000. J, 0.03. N is 12. Okay, simplify this one. Raised to the power of negative 12. Then subtract this from 1. Then divide it by 0.03. Then divide both sides of the equation by the factor of R. Then cancel out. So R is equal to 10,046.21 pesos. This is the withdrawal every year. So that at the end of 12 years, there is no more remaining balance. Okay, equivalent rates. Two varieties of compound interest are equivalent in case the investment of 1 peso. Take note that 1 peso is just an arbitrary startup value or value invested. Under each of the methods gives the same compound interest at the end of 1 year. For simplicity, we have only 1 year. Convert 6% compounded quarterly to its equivalent interest rate for monthly payment interval. Okay. These two interest rates must be equivalent so that this nominal rate 6% compounded quarterly must be equivalent to an unknown interest rate which is now compounded monthly. M equals 12. Okay. Now, we have compound amount F where G is equal to I over M, N is equal to MT. Substitute G with this one, N with MT. Our principal for simplicity is just 1 peso. Our time T is just 1 year. So substitute P with 1, T with 1, then simplified form. Okay. These two rates are equivalent if the 6% compounded quarterly must earn the same compound amount, F, with an unknown interest rate compounded monthly. So, F1 must be equal to F sub 2. Okay, using this formula, I is 0.06, M is 4, I is unknown, M is 12. Okay. In this equation, we have only one unknown I, an interest rate equivalent to 6%. Simplify the left side. Then we are going to solve for I. Raise both sides of the equation to 1 over 12 so that we can eliminate 12 on the right side. So this one will be cancelled. This is 4 times 1 over 12. The result is 1/3. Then extract the cube root of this number. Then transfer 1 to the left, becomes negative. Then cross multiply 12 so that I is equal to 0.0597 or 5.97%. This 5.97% is equivalent to 6% compounded quarterly. They are now equivalent. So the I this time is 5.97% compounded monthly. This interest per conversion period is equivalent to 6% compounded quarterly. Okay? So let us proceed to general annuity. An annuity where the length of the payment interval is not the same as the length of the interest compounding period. Example of general annuity, we have monthly installment payment of a car, lot, or house with an interest rate compounded annually. Take note, the payment is monthly and the compounding period is annually. So they do not have the same length of interest compounding period. Paying a debt of semi-annually when the interest is compounded monthly. So interest is compounded monthly. Paying semi-annually. Okay, let us have an example. Chris started to deposit 1,000 monthly in a fund that pays 6% compounded quarterly. How much will be in the fund after 15 years? Okay, so 1,000 is deposited monthly. So M is 12. And we have to determine a corresponding interest rate per month, which is equivalent to 6% compounded quarterly. So M equals 4. Okay, so using our previous formula, so I is unknown, M is 12, here I is 0.06, M is 4, simplify, combine and raise to the fourth power, or raise both sides of the equation by 1 over 12, so that we eliminate this exponent. This is reduced to 1 over 3. So extract the cube root of this number, then transfer 1 to the right, becomes negative, then subtract, then cross multiply 12. So this is actually the same problem previously. So the interest rate per period per month is 5.97%, equivalent rate with 6% compounded quarterly. So our I this time is 5.97%. So let us proceed in solving the problem. Okay, it is asking for how much as the future value f. So let us solve for G and N. So G is I over M. I this time is this value. M is 12. N is M times T. M is 12. T is 15 years. So the formula for the compound amount, or rather the future value, substitute R, the monthly payment, 1,000. J is this number, this value. N is 180. Okay, add, then raise to 180. Then subtract 1. Then divide by the denominator. Then multiply. So the monthly deposit of 1,000 every month after 15 years, it accumulates to the future value of 290,076.28 pesos. Okay. Next example. Ken borrowed an amount of money from Kat. He agrees to pay the principal plus interest by paying 38,973.76 each year for 3 years. How much money did he borrow if the interest is 8% compounded quarterly? Take note that the payment is every year. The interest, the compounding interest is 8% compounded quarterly. So we are going to determine the equivalent rates I for every year, because the payment is every year. The compounding interest period is quarterly with 8%. Okay, using the same method, using the formula of F, I is unknown, M is 1, I is 0.08, M is 4. Simplify the right side, then raise to the fourth power, then transfer 1 becomes negative. So I is equal to 8.2432%. So using this value of the interest per year, let us proceed in solving the problem. How much money did he borrow? So it is asking for the present value, P. So using the formula of P, let us have first the G and N. G is I over M. I is this value in decimal. M is 1. N is M times T. M is 1. T is 3 years. Using the formula for the present value. R is the payment every year. J is this value. N is 3. Okay. Add and raise to negative 3. Subtract this from 1. Then divide by the denominator. Then multiply. In other words, Cain borrowed 100,000 pesos. Then he paid 38,973.76 each year. Okay. Next, example 3. Mr. Ribaya received 2 offers on a lot that he wants to sell. Mr. Ocampo has offered 50,000 pesos and 1 million lump sum payment 5 years from now. Mr. Cross has offered 50,000 pesos plus 40,000 pesos every quarter for 5 years. Compare the fair market value of the 2 offers. If money can earn 5% compounded annually, which offer has a higher market value? Okay, we have here the given. Mr. Ocampo's offer, 50,000 down payment. Then after 5 years, a lump sum of 1 million. On the other side, Mr. Cross offer, the same down payment, 50,000 and 40,000 every 3 months or every quarter within 5 years. Okay, both amount is compounded annually. 5% compounded annually. Okay, for Mr. Ocampo, I is 0.05, M is 1. And for Mr. Cross, take note that he pays 40,000 pesos every quarter, and compounding period is 5% annually, 5%. So we have to look for an equivalent rates I, which is compounded every quarter, equivalent to 5% compounded annually. 0.05 annually is M equal to 1. Okay. So let us start with Mr. Ocampo's offer. Okay. So J is equal to I over M. Substitute. And N is equal to M times T. 5 years. T is 5. M is 1. Okay. For the value or the market value of the property is equal to down payment plus the present value of all the payments. Okay, let us proceed with Mr. Ocampo. So this is the offer of Mr. Ocampo, 50,000 down payment plus the present value of the 1 million after 5 years. So 1 million is paid only once after 5 years. So let us determine the present value, P, with this formula. Substitute F, 1 million, J is 0.05, N is 5. Okay, raise this to the negative 5, then multiply with 1 million, then add. So this is the market fair market value of Mr. Ocampo's offer. 833,526.17 pesos. After this, let us solve for the fair market value of Mr. Cross offer. Okay. So first thing we have to do is find the equivalent rates I equivalent to 5% compounded annually. Because the payment of 40,000 pesos is every quarter. M equal to 4. So using our method with this formula, so we have I equal to 0.05 over M1 raised to the M1. This one I is unknown over M is 4 raised to the 4th power. Simplify this one. Now extract the 4th root of both sides of the equation so that 4 will be eliminated. You cancel out 4. And extract the 4th root of 1.05. This is the value. Transfer 1 to the left becomes negative. Subtract. Then cross multiply 4 so that the interest rate per quarter is 4.91%. So we will use this 4.91% as our interest rate per quarter. Okay, so let us proceed with G and N. G is I over M. I, this value, M is 4. N is M times T. M is 4. T is 5 years. So 20. Substitute in the formula. Payment a payment of 40,000 pesos every quarter. Then J is this value. N is 20. Okay, erase this to negative 20. This is the value. Subtract this from 1. Then we obtain. Then divide by the denominator. Then multiply. Then this is the present value of the quarterly payment of Mr. Cross. So let us add this to its down payment. 50,000. So the total fair market value of Mr. Cross offer is 755,553.22 pesos. Now let us compare Mr. Ocampo's offer and Mr. Cross offer. Mr. Ocampo has this total fair market value and it's corresponding with Mr. Cross offer. Now let us subtract, take the difference. The bigger minus the smaller. The difference is 77,972.95. In other words, Mr. Ocampo's offer has a greater or higher market value. Okay, that's enough. Thank you.